Before we start, I have a small disclaimer to not disappoint anyone. There won't be any new tools today. There won't be new frameworks, new approaches, I guess. I will not also perform any kind of magic show here. There will be a few memes to make you laugh. And as mentioned in the invite, we will be talking about domain-driven design. However, no additional knowledge is required to understand the stuff I will be showing. Everything will be explained carefully. So if you will have any concern, any questions during my talk, do not hesitate to stop me and raise the questions. Okay, are you ready, guys? First things first, couple of questions from my side. How many of you are running new projects from scratch and took part in decision-making regarding tech stack? Okay. And how many of you were joining a project with a bit different tech stack that you had in your previous project? Okay, cool. So much more. And was it hard to understand those tech stack differences for you? Yes, no, a bit. Okay, a bit. And the last question, or like the one of the last one, was it hard to understand what the app is actually doing? And in your opinion, which one was more difficult? The tech stack differences or the domain or the logic responsible for which the app was responsible? Okay, definitely the logic. I thought so. So we as developers are often focusing on technology, trying to use the best tools in most modern or fancy way to develop well-performing code, well-tested. And it's nothing bad about that. Trying to be up to date with tech and building our own portfolios and learning new skill is not bad. The issue is when this is becoming our primary, if not the only thing that drives us in our daily work. We need to ask ourselves the question, why we were hired or why our company was hired by the customer. Of course, there will be the cases in which we were hired as some technological wizards or actually summoned by the customer as a wizard to fix some configuration or performance issue. But most likely we were brought to the customer to solve the business problem. The customer is not necessarily interested in whether we are writing our code in Kotlin 1.6 or Java 17 or Scala 2.16 or anything else. In most cases, he or she has an idea in which the idea should be provided to their own customers as a mobile, web, or even command line app. Sometimes we even need to help the customer choose the right approach, whether they should serve the website, whether they should serve the mobile app, or sometimes they should just display the Excel spreadsheet. And these days, having so many grateful tools like frameworks, like libraries, like cloud services, which are doing lots of stuff behalf in pre-configured semi-automated way, we should be able to focus more on the problem that our customer is trying to solve. And we should try to become the partners to our customers, partners who can advise them, even in their own business domain, because as we all probably know, sometimes devs are the best or the only source of knowledge about how the system works or even how the domain looks like. Which brings us to the topic of this presentation, the Kotlin and the domain-driven code. I guess we all written some domain code, or we will be writing soon, probably next morning. even though we might not think about it. And since we are gathered here as a Kotlin fans or lovers, maybe there are some haters too, I don't know, we will be looking into domain-driven code examples in Kotlin. A few words about me. I'm Michał. I'm a software developer at Bright Invention. I was playing an official role as a tech lead in my recent project. Unofficially, I was much longer time a team lead. And all the time I'm trying to be an architect, as every dev should be or try to be. And during working hours, I'm trying to solve the problem for the customer. Technically speaking, I've been married to JVM tech stack from the very beginning of my career. I was romancing with Node.js in the meantime and trying to be open for new experiences. Privately, I'm married to one woman, 2 kids, no romances. I love to travel and planning trips, as well as doing CrossFit, which I hope to go back after some break. But that's all about me. Let's move on. Domain-driven design, 3 words, huge book, lots of courses, blog posts, trainings. We could probably talk about it and argue about it for hours, which we don't have today. So in a nutshell, I would like us to treat DDD today as an approach in which we are focusing on business problem by separating code responsible for it from other aspects like communication, persistence, security, etc. So let's imagine everything like this is already in place. We are able to persist our data, retrieve it. We are able to communicate about the changes we made, or we are able to retrieve the information that something was changed. The only thing we need to do is to understand the business flow and code it. That's what domain-driven design is trying to help us focus on. Before we will jump into more technical things, let's clarify one more thing. Domain-driven design consists of 2 parts, strategic and tactical. As you might know, the strategic one is something bigger, more global than tactics. The same rule applies here. So whenever we are talking about strategic level domain-driven design, we have in mind the entire business domain and understanding how to divide it into smaller pieces that can bring value in an autonomous way. So as an example, we can talk about separating whole reporting in e-commerce business. It could work separately based on historical data, which we stored next to it. The tactical domain-driven design, it's more local. It's about splitting a certain subdomain of a problem into smaller building blocks that we can implement. That's the part we will be focusing on today. In his book, the father of DDD, Eric Evans, published the following graph of building blocks that DDD consists of, or in case of Smart UI excludes. There are some supporting patterns which are not mentioned here on the picture. However, they are really helpful implementing the business logic. We will talk about one of such patterns later today, which is called policy. But let's firstly take a look at 2 other things that we have in the middle of the graph, entities and value objects. So entities, they should be the first place to put our business logic as well as data needed to perform that logic. Let's remember that DDD stands in opposite to, like tactical DDD stands in opposite to anemic models, which we know from typical layered CRUD applications. Besides that fact, we can encapsulate definition into words, identifiable and distinguishable. We should be able to identify a single entity and distinguish it from other entities. Also, when we are talking about business rules in domain-driven design, we often use the word invariant. It means some unchangeable fundamental rule which should be protected by our logic. Since our entities contains both data and the logic and behavior, they might as well protect our invariants. They can also have a certain life cycle depending on domain. So let's jump into the code to see an example how we can protect the integrity of our entity, which is changing during the life cycle. Yeah, let me make it a bit bigger. And so here we have our tiny project. Let's leave aside the stuff that we are missing here, because I wanted us to focus on the identity lifecycle of a certain entity. Let's take the order as an example. So in domains in which we are operating on orders, when we are selling something or buying something, the order often come with certain life cycle, which we can express as a group of statuses, as I did here. So just to shorten, I created 3 statuses: received, accepted, and rejected. And of course, our order contains some identifier to uniquely distinguish from the other orders. And we have a couple of business rules here. One of them is the fact that the order cannot be rejected if it was accepted. The other one is the fact that only received order can be accepted. So I've put them into 2 functions. One is called reject. I can try to zoom a bit. The other one is accept. So they are checking the proper statuses, they are throwing the exception, and they are changing the statuses if this is applicable. Let's look at the test. So we have a few tests here. One is to check whether we can accept and received order. The other one is to check that the accepted order cannot be rejected. And the third one, which is parameterized, because we want to operate on multiple statuses other than received, we want to check that orders other than received cannot be accepted. So we are doing plenty of checks here. Actually, whenever we will be adding more statuses to our order, we will need to make more and more tests or test cases here. So let's look at the other approach, which might help us a bit with that fact. Here I have a different implementation of the order. I use the Kotlin sealed class, and I've created 3 implementations of our order. So we have the received order, we have rejected order, and we have accepted orders. What's the benefit of it? Let's look at the test here. The only thing that I need to check is whether we can accept the received order, because we don't need to check if the orders other than received cannot be accepted, because that's basically impossible in the code itself. We cannot create a accepted order and call accept method on it. We don't have such method. And also we don't need a test which is checking accepted order that it cannot be rejected. It's for the same reason we cannot do it for the accepted order. We cannot reject it because there is no such option in the code. So this is the nice thing we have in Kotlin, the sealed classes, and we can really use them to manipulate the state of our entities. Let's go back to the other part. Sorry that I need to play a bit with this thing here. Never mind then. Second thing, value objects. Sometimes we don't care about identity of certain thing, but we only look at the value. By value, we might mean one or more attributes which together make the object different from the other object. Suppose we have an object that represents weight. It contains the value, which is a number, as well as the unit. In Europe, it will be kilograms, in US or UK, pounds. So 30 kilograms are equal to other 30 kilograms, that's a fact, but 30 pounds are not equal to 30 kilograms. So our object does not have Our object does not have any identity. There is no need to distinguish between 130 kilograms and the other 30 kilograms. These are the same 30 kilograms. Such thing in domain-driven design is being called the value object. It represents something in our business domain, something richer than just a number or string. It holds some meaning of a certain value, like in our example, object represents weight of 30 kilograms. And we cannot compare it to something other like 30 centimeters or 30 years. It doesn't make any sense. So let's go back to our code and take a look at this example. So we have our value objects here. First, let's look at the order, which is without any value object. We have just an ID and the total amount, which is integer. I simplify it to just not work with the stuff like doubles or big decimals. So let's imagine that we are talking about the amount in the lowest denomination, like in tens, for example. And let's look at the test we have for our money. So we can sum up amounts from two orders. We can take we can create one order, the other order, we can take the total amount and sum it up. It kind of makes sense. We want to aggregate the orders. And we have the second test, can do whatever I want. So we can take the total amount, which is just a number. We can multiply it, we can divide it. But from business point of view, it doesn't make any sense. What's the meaning of taking, I don't know, 10 euros and divided it by 10 euros? It might be really error prone, especially when our system is growing. Someone is taking the amount, he is getting the number, he's trying to operate on that number. At some point, he's forgetting that it was really an amount of money, and he can do whatever he wants with just a number. And the second implementation is with the data class. So we have our money representation and encapsulated inside the data class. We have the currency and we have the amount, which is a number. And we have a method called add. So we can add one value of money to the other if the currency matches. If not, we will throw an exception. And we have the order that operates on that money. Let's look at the test. So we can sum up amounts from two orders when currencies match. So we are taking the money in Polish zloty. And in the second order, we also have the total amount in Polish zloty, and then we can sum it up, and we will get the money with value of 40. The second test shows us that we cannot take the orders with total amount from two different currencies, because there is no logical explanation to sum it up. There's no sense to take the money in British pounds and add it to the Polish zloty. We need to exchange them. So again, this saves us from error-prone behavior with our primitive values. It's also a good thing to fight against the well-known code smell, which is called primitive obsession. So that's about the value object. The third thing I want to show you today is the policy. So it's not the building block inside the Evans graph of the domain-driven design building blocks. But sometimes we might end up in some business logic that not necessarily belongs to certain entity or value object. It might depend on some external data or also on the data that sits inside some entity. For example, we might have taxes or taxification rules, which we want to apply to transaction, depending on what are the parties of the transaction, what is being sold, and in which country such transaction took place. So such rules could be nested inside transaction entity. However, some of the data needed to apply transaction taxification rules might not sit inside that entity. For example, the country or parties details. Also putting more and more business rules inside one object can make the object growing into tremendous number of lines, and it might make this object not strictly responsible for one thing. So we will break the single responsibility principle. Fortunately, policy is something that might help us here. It can be a place for a business logic that doesn't fit in any entity or value object, but extends the behavior of one of them. Implementation-wise, it's just a strategy pattern that can be combined with specification pattern to encapsulate the predicate. Additionally, we can use factory to separate creation of the object from its behavior. So let's take a look at the example how discount policy might work and how we can apply it to our order. Here we have our discount. So imagine we want to apply some discounts based on number of items and the customer status, whether he is in loyalty program or not. And discounts cannot be combined, and loyalty discount is more important than the number of item discounts. So here we have our order. I name it customer order because it contains also the customer data. It contains some order lines, which represents certain products with their quantity and the unit price. And inside the customer data, we have the ID, we have the name of the customer, and we have the Boolean flag telling us whether the customer is in loyalty program or not. And we have the draft order, like we made our homework and we are smarter, so we want to use the sealed class here with the certain life cycle being implemented by implementations of this sealed class. So we have the draft order and we have the purchase order. The draft order is something that sits in our basket before we will place an order. And the purchase order is something that is actually bought, and we are calculating the discounts at the moment that user clicks like finalize or purchase. As we might see in the purchase method, we have some of the logic responsible for discounting. So we are checking the total amount, we are checking the loyalty program, and we are checking the total quantity of items. And based on that, we are building the proper discounts, and we are applying these discounts to the purchase order we are creating. Let's look at the test. The tests are pretty clear. We have we are checking the total amount for order not eligible for discount. We are checking for one type of discount, for the other type of the discount, and we are also checking how the code behaves whenever we have both preconditions met for both types of discounts. So we wanted to have the loyalty more important than the amount discount. So this is pretty fine, although we have our purchase order responsible for, or maybe not the purchase order. We have this this order flow responsible not only for changing from draft order to the purchase order, but also it's responsible for applying discounts. If our, let me call it, discount logic will grow, we will end up in in huge purchase method or like different private method nested inside our order. The other approach I took, let me show it, is using the policy. So I've created the customer order. We still have the draft order and the purchase order here, but we have also something called discounts policy, which contains two methods. One is apply, or actually, sorry, we have like one method, apply, to apply the discounts to the order. And we have the object here, which is responsible for no discounts policy. So whenever, like by default, we have no discounts, so we'll just return the same draft order. And we have the total items policy. So we are checking in is acceptable method, we are checking whether the total quantity is greater than 2. And we have the apply method, which is actually calculating the discount. So we are giving the 5% discounts to the customer whenever we will meet the condition. The second option is the loyalty program discount, and we are also doing similar stuff. We are checking the preconditions here, and here is the place for the specification pattern. So we might extend this in the future. And we have the apply method, which is giving us 10% discount. And we have something called discount policy factory. So we have the object responsible for applying or giving us the certain discount policy, depending on the order. So if the discount policy is the loyalty program discount policy is applicable for the order, we will be returning the loyalty program discount policy because it's more important than the total item quantity discount policy. And if not, we will just return the no discount policy. And the tests looks as follows. So the test grew a bit because we have the test responsible for one of the policy, the other one, we have the tests responsible for the factory, and finally we have the test of our draft order. The thing is that we have like the responsibility separation here. So the draft order is only checking whether it can be purchased with discount policy. We don't care which policy is it. We have the factory test, which is telling us how we are managing the order of our policies, whether it matched the requirements. So we are checking if the discount policy for loyalty program is more important than the total quantity, and if we have no discounts policy, if any other matches. And the same goes for the two of those policies. So we are checking how they are behaving. So it's a bit more code, but I would say it's like the responsibility is split into 3 different places, and one of them is responsible for like moving or from certain state to the other when it comes to orders. The other one is responsible for choosing the right discount policy, and the third are the policies responsible for applying certain discounts. Let's go back here. Besides that, we have other building blocks from Evan's book. I will not be talking about them today. I will just mention that the hardest thing for me was to understand the aggregates and the boundaries of those aggregates. Repositories, factories, and services are much easier, in my opinion, as we already know what we might expect from them, as we get used to using the technical reflection of those patterns. So we get used to use repositories in our ORMs, and we get used to factories of objects and also services in the layered architecture. So that's it from me. Thank you all. Are there any questions related to the topic?
Maybe on the chat. Jakub, could you check? No, on the chat. Okay, so thanks, Michał. And as a thank you, we would like to give you this T-shirt so that you can wear Kotlin logo on your chest. So thanks.
Thank you very much.